All right, so warm up 96 should be just about done. Sketch bell curve, compute the z-score for number 13. And number 2, compute 6 factorial divided by 2 factorial minus 5 factorial. See how you do with that? I'm going to be recording this session, even though it's a review of what I left you yesterday. I just want to make sure that everybody's on the same page because we're about to move on from counting rules. Okay. And then this week's a short week. We have a minimum day tomorrow. I'm all, what? Totally forgot about that. Then we're closing grades already for the third quarter. Let's go. How's everybody doing with their grades? Good? Yeah? 100%? Let's go. I guess now that the fair is gone, I think we should be on top of everything, yeah? Yes, Mr. Q. All right, good. All right. As you send that in, here's the agenda for today. Warm-up number 96, combination rule. And tonight's home play fix counting rules problems only. All right, we good? So I am recording, like I said, recording this session, and just a reminder, third quarter ends, and I'm closing grades. So Thursday, I'm going to turn those in by Friday, so that should be in. So do me a favor, get your cell phones out, go to Canvas, go to Grades, My Class, take a screenshot, get that signed so that you know where you're at, so that your parents know where you're at. And once again, if you are still missing assignments or need to make up any pop partes, seeming, or do that ASAP, please. All right, so 6 counting rules, I'll show you that at the end. And here we go. I can identify and compute the combination rule in probability. I can identify and compute the combination rule in probability. I can identify and compute the combination rule in probability. So we already know where we're at with the probability section. And we covered fundamental. We covered permutation. And today I'm going to go over combination rule one more time. Like I said, I left you a video lesson. Hopefully it made sense, but here it goes one more time just to make sure. And combination rule. Check your notes. Make sure that you have this formula. Write it down, the rule. I'll give you guys some time. And once again, I don't know if you guys noticed, this is very similar to the permutation rule. Is that correct? Yes, Mr. Q. Just to recap, this rule right here, combination rule, is when order doesn't matter. Make sure you write that down because you're going to need that to differentiate which problem from which. When order doesn't matter. Permutation, when order does matter. And once again, N is what? Total objects. And R is the selected objects. Pretty clear so far, yes? All right. So let me just go back one more time. So let's see. Remind your neighbor the 2 rules that we covered for fundamental counting rules without looking at your notes. What were the 2 rules? Talk with your neighbor. 2 rules for fundamental. All right, Diego, give us one, since you guys are very talkative. N times N minus 1 times N minus 2 dot 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 and so on. And this is known as what? Factorial. So that was one rule. What was the other rule? Pass someone, Diego? Joseph, I'll start with the letter K. Times. Dot, 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 and so on and so forth. And this is the fundamental counting rule where we saw the different events and we multiply the total number of the events for each, and that gave us the counting rule. How about permutation? Remind your neighbor permutation. Pass that one, Joseph. Chelsea. Factorial. That is correct. All right. How about combination rule? Areli, what do you think? R, okay. Times R factorial. Yeah, that is correct. So notice the difference, but the only, I guess the difference between one to the other, here the order matters. You know, here order doesn't matter. All right. So we got our rule. There you go. And here goes one more time. You guys should have these notes. So if I was to use my combination rule, all right, tell your neighbor what N is and what is R. What is N? What is R? What is N and what is R? All right, Fernando, N. 8 and R, 3. So this is 8 factorial over 8 minus 3 factorial times 3 factorial. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, this is 4 factorial, yes? 4 factorial, which is 4 times 3 times 2 times 1. However, times 3 times 2 times 1. So these are giant ones. Yeah. Where is it at? Oh, 5 factorial. My bad. Yeah, I did that to see if you were paying attention. 5 factorial. There it is. So therefore, that leaves us with 8 times 7 times 6. That is what? 6 as well? Yeah. Did I check out the 6 on the notes? Yes? So 3 times 2 times 1 is 6, and 6, that leaves us 56. Is that correct? All right. So far, so good? Yes? And you have these notes. Okay. Let's go to the next one. And here, that's when we start using more of the combination of both. So I somehow said, well, here we have women and men in this problem, but they combined for a committee. So once again, women and men. Yes? So that means I need to do a combination of NR less for the women times a combination NR of the men, and that's going to give me a total of totals. Is that correct? So therefore, help me out with combination for a woman. Jay, go. Jaden. J-Dub, go. C, without looking at your notes, you can just look up here. What is the total number of women and the selected women for the committee? So, what do I write? Factorial. Factorial times factorial, yes. So this is 7 times 6 times 5 times 4 times 3 times 2 times 1 over, this is 4 factorial, 4 times 3 times 2 times 1 times 3 times 2 times 1, which is this one. So, then 3 times 2 times 1 is 6. Therefore, 7 times 5, that's 35. Yes? So I have this one. I'm going to write it over here. 35 times, now this one. Help me out with the men. Jaden. M. Montes. Go. Tell me what to write. So this is 5 times 4 times 3 times 2 times 1. And then this is 3 factorial, so this is 3 times 2 times 1 times 2 times 1, which is this one. So 2 times 1, I'll just leave it as 2. 5 times 4 is 20. Divided by 2, that's 10. Is that correct? So now that I have this part, which is this part, so the total combinations are 350. We good?
It's only $10.
All right, back to our regularly scheduled program. We good with this one? Yes? All right. And look at this example. Baseball players with baseball players, basketball players and basketball players. So notice that it's very similar to the one we just did, yes? All right, so let me assign you the screen so you can send me these notes that you already have. I want to see that you wrote these notes. Give me a second. Thank you. So, questions with any of the 3 rules that we covered so far? We good? All right, so brings us to the practice problems that I mentioned in the video. Let's talk about this one. How many different ways can 4 tickets be selected from 50 tickets if each ticket wins a different prize? Keyword here was what, everyone? Different prize. That means that each one that you pick out is different. That means it has a specific role, which means what? Which formula would you use? Permutation or combination? Talk it with your neighbor. Permutation or combination? Which rule? Chuffy! Permutation? That is correct because it does have a specific order. So copy the formula, P of NR, and then find me how many different ways, please. I'll give you time. Go. All right, thank you. Example, Super Q. The Foreign Language Club is showing a 4-movie marathon at subtitled movies. How many ways can they choose 4 from 11 available? Question. Which rule shall we use? And does it matter? Does the order matter? Do they give us a rank of the movies in regards to which ones are the favorite ones or anything? No. So they just give a selection of movies. Does it really matter the order? No. So therefore we use what? The combination rule. So C of N R. All right. So find me the total combinations, please. Let me send you the screen for that one. Okay, we good? Thank you. Next one, how many ways can an advertiser choose 4 students from a class of 12 if they are all assigned the same task? First question, before you move on. Here's the first question once again. How many ways can an advisor choose 4 students from a class of 12 if they are all assigned the same task? So if they are all assigned the same task, does the order matter? So tell your neighbor which formula you're going to use for question number 1. Which formula, Briseida? Combination or permutation? That is correct. C and R. Look at the second question. How many ways can students be chosen if they are each given a different task? So this one is what, everyone? Permutation. All right, so find me both. First for the first question, then the second. On the video lesson, I assigned 6 problems. There they are. So make sure you go to Canvas, turn that in. I'm going to leave that open till 3:25 today, just in case some of you were absent and you didn't see that assignment. But there they are. And I'm going to stop the video lesson at this point. You have the rest of the period to work on these and finish them up. Enjoy. Those of you that are following on YouTube, enjoy your extra practice. See you later. Bye.